Hello, and welcome to our program, Astronomy for Everyone. The topic for this month's show is the topics of Chile. And here to tell us all about this is our guest, Dr. Nicolle Zellner. Nicolle, welcome to the program.
Hi. Hi, Don. Hi, everybody. Thanks for having me. I'm really excited to tell you about my trip to Chile, where I learned all about the best telescopes in the world.
So before we get into that, Nicolle, can you tell our audience a little bit about yourself?
Sure. I am a professor of physics at Albion College, so just down the road in Albion, Michigan. My research specialty is planetary science, and in particular, I study lunar samples, samples from the moon that were collected by the Apollo astronauts over 50 years ago. And in these lunar samples, I'm interested in studying the impacts in the Earth-Moon system and what they might tell us about the conditions for early life on Earth. I grew up in Wisconsin in a small town outside of Oshkosh. And while I was growing up, I immediately over time, I guess, developed a love and a passion for the night sky and for astronomy topics in particular. I did my undergraduate work at the University of Wisconsin in Madison and my graduate work at Rensselaer Polytechnic Institute in upstate New York. I have been at Albion for almost 20 years. So I'm happy to call Michigan home now, for now.
Okay. Well, we're glad to have you, and it's interesting to hear all about your work, especially, I can say, with the moon samples from the Apollo program. Now, can you tell our audience about this program with the telescopes down in Chile?
Sure. So this is a national program called Astronomy in Chile Educator Ambassador Program. Sorry, I flaked on the acronym there for a minute. ACEAP. So it doesn't really roll off the tongue. But what it is, it's meant for people who are educators, who are teachers, who are artists, who are photographers, who are park rangers, for people who have an interest in helping to spread the good word about astronomy to the general public. So in 2018, I was accepted into the 2018 cohort, which included people from Washington State, from Florida, from Ohio, from Illinois, and other parts of the country, Oklahoma. We had a Teacher of the Year in our cohort. We had a park ranger, nationally recognized park ranger in our cohort. We had several high school teachers, a planetarium director, 2 college professors, and a graduate student, as well as a liaison to Chile itself, a high school physics teacher from Chile. And this cohort of people was led by Tim Spook, who is part of the Associated Universities Incorporated, AUI, which was the which is the host of the ACEP program. So we had been applying, all of us, over the course of a few years, and in 2018 we came together to travel down to Chile for about 2 weeks in order to learn about astrotourism and also learn about the National Science Foundation funded telescopes in Chile.
So interesting that they're actually promoting astronomy tourism down in Chile. Is this a fairly recent thing, as far as you know?
Well, I think with the realization that both the National Science Foundation and the European Space Agency and other national funding agencies around the world are building telescopes in Chile, the government has adopted the belief that astrotourism can be a real income generator for the country. So Chile is unique in that it has a location with high mountains, dry atmosphere, and very little moisture. The mountains block a lot of the moisture coming from the Amazon to the east, and the Humboldt Current, which runs up the coast of Chile, blocks a lot of moisture coming from the oceans on the west. And so it's got a really unique climate that makes it really ideal for high altitude telescopes. Telescopes that need to be high up above the ground, above light pollution, and able to see really nicely into the night sky and into the universe back into time. And because of this beautiful location for scientific observations of the sky, the Chilean government is promoting astrotourism as well, and also astrotourism with its wine industry in order to bring tourists to Chile to see some of these beautiful skies without light pollution, tour some of the wineries, really get to know the local culture, and develop an economy based around tourism.
Sounds interesting. Wine and stars.
Right, wine and stars. What could go wrong? What could be more perfect? Yeah. So it's really a neat. It's a neat combination. And I think what else I want to say, what I think I should say about this too, is it's not just the space agencies and the National Science Foundation coming in and building telescopes on the mountaintop and then forgetting about it. Part of the deal is that 10% of the telescope time goes to Chilean astronomers. And so there's a guaranteed time slot for Chilean astronomers to actually use these very large and powerful telescopes to observe the night sky and to pursue and advance their own science. And I think that's a really, really great partnership.
It sounds like it is. Now, let's start talking about some of the telescopes themselves. We'll start with Cerro Pachón. What can you tell us about that?
Yeah, so unfortunately, our group didn't get to go up to the summit of Cerro Pachón because we were snowed out. We were there in June or July of 2018, which of course is the is winter in the southern hemisphere. So when we're up at these very high altitudes, there's snow on the ground, and there had been some big storms that came through. So we were not able to go to the summit of Cerro Pachón. But at Cerro Pachón are three major telescopes. One is the SOAR telescope, which is the Southern Observatory for Astronomical Astrophysical Research. Gemini South is located there as well, and Gemini North is on the summit of Mauna Kea in Hawaii. So these are twin telescopes, identical in almost all respects to each other. One is situated in the northern hemisphere, and one is situated in the southern hemisphere. Gemini, of course, means twin, so we've got Gemini North and Gemini South. And then the newest addition to Cerro Pachón, the Vera Rubin telescope, which once it's fully commissioned, will scan the night sky, the entire night sky, every 10 days for years. And in these broad surveys of the night sky, the Vera Rubin telescope will be able to identify transient events like supernova, mergers of celestial objects, and potentially even asteroid and comets. So it's a really, really powerful telescope that's going to allow us for years, right, to see changes in our night sky. Terabytes of data will be collected every night when the Vera Rubin telescope is up and running to full capacity. So really, really cool astronomy that's being done on Cerro Pachón.
Do we have a date when the Rubin will be fully operational, do you know?
Probably. That's easily Googleable. I don't know that date off the top of my head.
Okay.
Sorry.
No, that's okay. That's okay. Just a question that popped into my head as you were.
Oh, of course, right. And as soon as I said it, I was like, oh, I should know when that is. I should have done some homework.
So, and this will, because it's in Chile, this will be covering primarily the skies of the southern hemisphere?
Yes, right. Once you get below the equator or above the equator, you're really sighting yourself on that very specific part of the celestial sphere. It's only within a few degrees of the equator itself that you get a chance to see both north and south. Though I will say, on some of our more touristy stops, when we went to some private observatories, it was fascinating for me as a girl up in the north hemisphere to see the Big Dipper so low on the horizon. Looking north, that Big Dipper was on the horizon rather than up 44 in Michigan here, up at 45 degrees above the horizon, right? So that was like a little bit mind blowing for me.
Yeah, it would be a change for those of us who are just used to the northern hemisphere to get the perspective of being south of the equator.
Yeah, right? I mean, the constellations are upside down and backwards. The shadows, the shadows are in the north instead of in the south. The sun's moving across the sky in the north instead of the south. It took me a minute. I spent my first sabbatical in Australia in 2011, so I got my first taste of it there. And then I had to, it took me a day or two to like kind of reorient myself and remember again how the sky is differently configured in the southern hemisphere compared to what I'm used to in the north.
Yeah, it would take some getting used to for sure. Well, we're going to take this opportunity, Nicolle, to take a quick break. If any of our viewers have a question, please send us an email. As always, you can see that address down at the bottom of your screen. And coming up next is Term of the Month with Stephen, and after that, we'll be back.
Thanks, Don. The term of the month is kilonova. A kilonova is an explosion in space caused by a pair of neutron stars merging. They aren't as bright as a supernova, but they are 1,000 times as bright as a nova. A study published to the arXiv preprint server shows that the risk to Earth of a kilonova is very low. That's really good news. The study is based on a neutron star merger observed in 2017. It was detected as a gamma ray burst and gravitationally as a compact object merger. We have a good idea of the mass, distances, and energy produced. The team used simulations to augment these data. There are three main threats from a kilonova. X-ray emissions from near the polar regions could be a threat at about 16 light years away from us. Gamma rays produced by the explosion scatter off interstellar particles, so are a threat at 13 light years. These come at the speed of light. Not surprising, since gamma rays and X-rays are light. The shock wave creates an expanding shell of cosmic rays at a lethal range of about 36 light years. This is one of those astronomical distance things where 36 light years is too far to walk, but turns out to be too close to be very likely. Still, we'd see the light show before feeling the cosmic rays. And that is Term of the Month. Back to you, Don.
Thanks, Stephen. We're back here talking with Dr. Nicolle Zellner, professor at Albion College here in southeastern Michigan, and she's telling us all about her trip to see the telescopes of Chile. Now, Nicolle, we're going to move on to another part of the country to check out the telescopes of Cerro Tololo.
Yeah, visiting Cerro Tololo was really amazing. We landed in the beachside community of La Serena and spent a night there where we did a little bit where I first learned and first did my very first astrophotography. My good friend who I met there, Samara Nagel, who's a beautiful astrophotographer, helped me get my digital camera kind of set up and start taking some exposures in practice for what was going to happen at Cerro Tololo. And we made our way to the observing site, which is around 7,200 feet, and set up our telescopes to take pictures of the night sky, pictures of the Milky Way, pictures of the large and small Magellanic Clouds, which you can only see in the southern hemisphere. And even for somebody who had never done astrophotography before, the skies at Cerro Tololo made it really, really easy to try to take some nice pictures. We ended up staying in the astronomer dorms up there, and It was a beautiful, clear night, as you can see in Sam's picture there of the Milky Way. And I really need to give full credit to her for taking that beautiful panoramic picture of the Milky Way. The southern hemisphere is the best place to look at the center of our galaxy. So in that picture, you will see a region of the Milky Way that is really, really brilliant, where we see a lot of high energy events happening, supernova events, where our galactic center is located. So being able to see some of this with my own eyes was really, really awe-inspiring. The Milky Way, the skies are so dark there, the Milky Way is so bright that I literally saw my shadow in the snow by the light of the Milky Way. And I have never experienced anything like that before. And it was an amazing, amazing experience. We all stayed up all night taking as many pictures and experiencing the dark skies as much as we could.
Understandably so. That image is just absolutely amazing. You can see the bright galactic center and the large and small Magellanic clouds. Awe-inspiring is a pretty good word, actually.
Yeah.
So, yeah, I can understand why you wouldn't mind being a little sleep deprived the next day.
Yeah. Yeah, so, and a little cold throughout the night, I'm not going to lie.
Yeah. Oh, for sure, for sure. Now, there are some interesting telescopes there at Cerro Tololo, including the Blanco 4 millimeter, or meter, I should say, not millimeter.
Yep, yeah. So the 4 meter, the Blanco is set up with the Dark Energy Survey, which is a U.S. Department of Energy office science-led project to try to get a handle on the dark energy that we believe exists in our universe, and is one of the reasons why we think our universe is accelerating in its expansion. This idea was proposed by a few Nobel laureates back in the mid-2000s or so, and this idea of dark energy was proposed to explain this observation of our universe accelerating in its expansion. So the Blanco is set up with this detector and scans the night sky, collecting data. But other countries around the world, as well as amateur and for-profit telescope companies, have also built observatories on Cerro Tololo, and I think there's an image there that shows all the telescopes across the mountain, kind of a not a panoramic, but a kind of a long shot view. This is affectionately known as the mushroom farm, because these domes all look like little mushrooms popping up along Cerro Tololo itself. So the Space Agency in Korea has a series of domes there, along with some dorms for the Korean astronomers. There are some remote telescopes there that people can apply for time in just over the internet, including school groups. And then there are observatories on there from other countries and other U.S. Companies and universities as well. So really great place, 7,200 feet up above sea level, right? You're really getting up above the light pollution from La Serena. You're getting up above the moisture from the ocean as well.
And did you notice any particular problems with breathing at that altitude?
Not so much at 7,200. My sister lives in Denver, so I'm pretty okay at that kind of altitude. Though, of course, we did have advice, to breathe slowly, pace ourselves, that sort of thing. So we took that advice. Oh,
that's good. That's good. Besides the Blanco and the other scopes, is there anything else particular about Cerro Tololo? Or is that pretty much it?
It's an observatory with 40 telescopes, or a mountaintop with 40 telescopes on it, right? From some of the view, from one of the eyepieces, which I thought was really fascinating, you could actually see another mountain range where the European Space Agency has built its largest telescopes, including some of these telescopes like the extremely large telescope or something like that. And so that was kind of neat to be able to look across the mountain range and see other observatories, very faint
Interesting. Now,
Places
I'm sorry, go ahead.
Yeah, no, just I'm saying, you know, you could barely see the outline of these other observatories, but they're there too.
Oh, okay, interesting. Now, what about ALMA?
Yeah, so ALMA is the Atacama Large Millimeter Array, and that is located in northern Chile, pretty close to Bolivia. So we traveled by plane then to the ALMA to La Palma, which is the very rustic city town, if you will, where the just outside of where ALMA was created. And ALMA is an international partnership with Japan, the Japanese Space Agency, the European Space Agency, and the United States to collect radio signals. And so what's really great about ALMA is that they have this array of 66 radio dishes. Most of them are about 12 meters across. They have been built they're European, they're Japanese, and they're American, and they're all working together to create these very large fields of radio dishes that can be moved out on tracks to act like really, really large telescopes, much larger than the 12 meters they are, in order to collect radio signals from very deep space at a very high resolution that allow us to see amazing detail in star-forming regions, planet-forming regions, and other parts of the universe. So, and one of the pictures there shows this very dry Atacama Desert. It's often used for experiments as a Mars analog. So people will put microbes up in the Atacama in this very dry desert region and see what happens to them over time, as if they were using it as a Mars test site. And then the radio dishes themselves are located at 11,000 feet. And here, I actually did take oxygen at 11,000 feet. And some others of my team did as well. And we were able to stay up there for about an hour and walk pretty close to the radio dishes. I can't recall if they were actually in configuration, if they were actually observing anything at the time. But to be that up close and personal was pretty, again, pretty awe-inspiring, pretty neat to be able to stand among these radio dishes that were collecting such amazing science about our universe.
Yeah, it is. I've seen some images of ALMA, and to watch them move out on those tracks in such a large array to act as a giant interferometer to whatever the diameter of that spread of the tracks is, it really, as you say, picking up all sorts of data with all those scopes.
Yeah. I mean, not only detail in planet-forming regions, right? You can actually see planetesimals colliding with each other, or the result of planetesimals colliding with each other. But we've also detected molecules, pretty complex molecules, that are only detectable in the radio wavelength range. And we're learning more and more about all of the chemistry that's occurring out in space, too. Stuff that we didn't even think could be made out in space. We are observing with the ALMA telescope. The telescopes, and that's pretty incredible, because it helps us understand just how common this sort of interstellar chemistry is.
Truly, truly fascinating. Nicolle, I want to thank you for taking the time to talk to us and our viewers about your experiences with the telescopes of Chile. To our viewers, please check the club website. Address is down there at the bottom of your screen. And coming up next with What's Up in the Night Sky is Stephen.
Thanks, Don. What's up in the night sky for November 2023? Days are getting much shorter, real fast, here in the north, and much longer in the south of the equator, as we head toward the solstices. So November starts with a third quarter moon on November 5th. Then on the 13th, we have a new moon, which you won't really see. First quarter is on the 20th, and finally the full moon on the 27th. Then we have a bunch of planets: Saturn, Pluto, Mercury, Mars, and so left to right. Saturn is in Aquarius and sets 6 hours before sunrise to 8 hours before sunrise by the end of the month. Pluto is in Sagittarius, where it's been for quite a while. It sets sunset 5 hours after sunset to 3 hours after sunset, and so it's a little better at the beginning of the month. You have more time. Mercury goes from Libra to Sagittarius over the course of the month and sets from about sunset to about an hour after sunset. So that's better at the end of the month. And then we have Mars in Libra and going to Scorpius over the month. It has superior conjunction on the 18th of November, so it's going to be a real tough to spot Mars all month. Then we have Venus, also shown on the, now shown on the first of the month. We were just at the end of the month. This is at sunrise. Venus goes from Leo to Virgo over the course of the month and rises about 4 hours before sunrise all month long. It does some wiggling, but that's it. That's all we get. Then finally we have Uranus, Jupiter, Neptune, and Saturn is shown again. And this is shown on the 1st also. Uranus is in Aries. It's up all night because it has opposition on the 13th. Jupiter is in Aries and is also up all night. Its opposition is on the 3rd. And then Neptune goes from Pisces to Aquarius and sets 4 hours before sunrise to 5 hours before sunrise. Neptune essentially never moves from one constellation to another. I mean, it has to do that eventually, but it has such a big orbit that it takes forever to get across a constellation. It's been in Aquarius for the entire duration of the show since we started in 2009. And that is what's up in the night sky for November 2023. Remember, we do not charge money for this show, but we may tax your brain.